So in the last video we looked at the power equation and the work done equation, and we had three equations that came out of the last video. The first one was work done equals force times distance. Next one was power equals work done over time. And then lastly we derived the equation for power equals force times velocity. So they're the three equations that we learned from the last video. So now we're going to look at a power example, and this is from the Foland's book, page 217, so you have it there as well if you want to look at it as well as the solution. So we have a car of mass m is travelling on a straight road and the power output is 100 m watts. So watts are the unit, don't get the m and the watts confused. The car has initial speed of u0 and a final speed, or u2, of 2u0. So its final speed is twice its initial speed. Show that the time taken is given by the equation t equals 3u0 squared over 200. Well, just to get our other set of variables here, remember the first time is always 0, and then our second time is what we're looking for, which is what they're saying here is 3u0 squared over 200. So these questions are very similar to the other ones we've been doing, but we just need to get our initial equation first of all. So what do we know? Well, we know power equals 100 m, and we know our equation for power is F times V. If we rearrange that, we get F equals 100 m over V. Now in all of these questions we're looking for an equation with acceleration. So this is the reason why I rearranged this so that we have F on one side. Because we also know that F equals ma. We can now replace that F with ma equals 100 m over V. And our m's will cancel, and now we have a equals 100 over V. And this is just like a simple version of the other questions that we were doing. So now we just have to solve it. So we're looking for a relationship between velocity and time. So that means instead of acceleration, we'll use dv dt, because these are the two variables that we're looking for the relationship between, equals 100 over V. Rearrange that and we get v dv equals 100 dt. I want to integrate both sides, and I'll take the 100 out because it's a constant. Our initial velocity was u0, our final velocity was 2u0, our initial time was 0, and our final time was t. So that will give us v squared over 2 with our limits of integration 2u0 over u0 equals 100 t and 0. So that's 2u0 squared, and remember it's all squared, so put it in brackets, over 2 minus u0 squared over 2 equals 100 times t, because that will be t minus 0. I'll multiply across by 2, and that gives us 2u0 all squared minus u0 all squared equals 200t. 2u0 all squared is 4u0 squared, and that's why the brackets are important, because otherwise you might forget to square that 2. Minus u0 squared equals 200t, which is 3u0 squared equals 200t. And we're looking for an equation for t, and if we divide across by 200 we get t equals 3u0 squared all over 200, which was what they asked us to find in the question. QED.